In October 2021, a small Swedish company dropped a video on the internet that changed everything. A man sitting in what looked like an oversized drone, no doors, no roof, no windshield, flying through an Italian forest at 60 miles per hour, weaving between ancient trees like a scene from Return of the Jedi. That video exploded. Hundreds of millions of views. Every major news outlet on Earth covered it. And overnight, the Jetson ONE became the most famous personal aircraft the world had ever seen. Bookings sold out almost immediately. The wait list stretched into years. Celebrities wanted one. Entrepreneurs wanted one. Governments wanted to understand what it was. At $92,000, the Jetson ONE was impossibly affordable enough for ordinary people to dream about owning one. But here's the thing about success. When you create something the entire world wants, the entire world starts trying to copy it. And right now, thousands of miles from Jetson's workshop in Sweden, in the sprawling factory districts of Shenzhen, China, companies are building aircraft that look almost identical to the Jetson ONE. Same layout, same open cockpit, same four-arm, eight-rotor design, but at nearly half the price. In this video, we're going deep. We'll break down the Jetson ONE, what makes it special, how its design evolved, and why it costs what it costs. Then we'll pull back the curtain on the Chinese competitors trying to dethrone it, who they are, what they've built, and whether their aircraft are genuinely comparable or dangerously cheap imitations. And if you stick around until the end, we'll reveal the shocking price gap between the Jetson ONE and its most aggressive Chinese rival, a number that could reshape this entire industry. Let's get into it. To understand why the Jetson ONE matters, you have to go back to the beginning. Jetson Aero was founded by two men, Thomas Patan and Peter Ternström, working out of a small facility in northern Sweden. Their goal was deceptively simple: build a personal aircraft that anyone could fly. Not a billionaire's toy, not a military prototype, a real purchasable flying machine for regular human beings. But simple goals are rarely simple to achieve. Personal aviation has been the graveyard of ambitious startups for decades. The engineering challenges are enormous. The regulatory hurdles are brutal, and the safety requirements are, rightfully, unforgiving. For every company that succeeds in this space, 100 others burn through their funding and disappear. Jetson didn't disappear. They iterated relentlessly. The Jetson ONE you see today is not the first version. It's not the second. It's not even the fifth. The aircraft went through numerous design iterations, each one refining the frame geometry, the motor placement, the battery configuration, the flight control algorithms. Every crash, every wobble, every unexpected behavior and testing was fed back into the design. The final product is the result of years of trial and error that most people never saw. And when it was finally unveiled to the public in October 2021, the world lost its collective mind. Here was an aircraft that weighed just 190 pounds empty. It had four arms, each carrying two coaxial electric rotors, 8 motors total. The cockpit was an open aluminum roll cage. No fancy composite materials, no pressurized cabin, no million-dollar avionics suite. It's just a lightweight frame, a seat, a joystick, 2 battery packs, and the freedom of vertical flight. It was, in the most elegant way possible, a quadcopter drone scaled up to carry a human being. And that simplicity was precisely the point. The Jetson ONE was classified as an ultralight aircraft under FAA Part 103 in the United States, meaning no pilot's license required. No medical certificate, no formal training mandate. You could technically buy one, watch some tutorial videos, and go fly. At a starting price of $92,000, demand was volcanic. The first production slots sold out almost overnight. Wait lists ballooned, and by September 2025, Jetson began delivering aircraft to paying customers around the world. Yes, the dream of personal flight, a dream that humanity had been chasing since Leonardo da Vinci sketched his flying machines 500 years ago, was finally real. But success has consequences, and the biggest consequence of the Jetson ONE's triumph was about to arrive from the East. Before we talk about the competition, we need to address something that's been frustrating Jetson fans worldwide: the price. When the Jetson ONE launched, $92,000 felt revolutionary. Yes, it was serious money, But for a personal flying machine, a real aircraft that actually works, it was remarkably accessible. People compared it to the price of a pickup truck or a mid-range Tesla. But economics are unforgiving. The Jetson One's high demand and deliberately limited production created a classic supply-demand imbalance. Jetson is a small company. They don't have the manufacturing capacity of a major aerospace firm. Every aircraft is essentially hand-built with meticulous attention to detail. Quality control is tight, production numbers are small, and when demand dramatically outstrips supply, prices rise. That's not greed, that's physics. The physics of economics. Today, in 2026, the Jetson One costs approximately $128,000. And according to the latest announcements from the company, that price is expected to climb to $140,000 in the near future. That's a 50% increase from the original price. And while the aircraft has received continuous improvements, better software, refined components, enhanced safety features, the sticker shock is real. A machine that once felt accessible is slowly drifting into luxury territory. This price escalation created a vacuum in the market, a gap, an opportunity. And if there's one country on Earth that has mastered the art of identifying market gaps and filling them at scale, it's China. To understand why Chinese competitors emerge so quickly, you need to understand the Chinese drone industry. China doesn't just make drones. China dominates drones. By some estimates, Chinese manufacturers produce over 70% of the world's commercial and consumer drones. Companies like DJI have become household names, but beneath DJI sits an enormous ecosystem of hundreds, possibly thousands, of drone manufacturers, component suppliers, software developers, and engineering firms. Shenzhen alone, a single city, contains more drone expertise per square mile than anywhere else on the planet. You can walk into an electronics market in Shenzhen and buy brushless motors, electronic speed controllers, flight controller boards, lithium polymer batteries, carbon fiber propellers, Akra and GPS modules, everything you need to build a drone, off the shelf, in bulk, at wholesale prices. Now here's the critical insight. The Jetson One, despite its brilliance, is fundamentally built from drone components. The motors? Standard brushless outrunners commonly used in heavy-lift drones. The propellers? Carbon fiber blades similar to those on agricultural spray drones. The batteries? Lithium polymer packs without exotic cooling systems. The flight controller? An advanced but conceptually familiar stabilization system running well-understood algorithms. It is very likely, almost certain in fact, that Jetson sources many of its core components from Chinese suppliers. The joystick, the motors, the propellers, the battery cells, was the electronic speed controllers. These are components that China manufactures at massive scale for the global drone industry. And this is where the competitive advantage flips. Chinese drone companies don't just have access to these components. They have direct access, they know the suppliers personally, they can negotiate bulk pricing that foreign companies simply cannot match. They have existing relationships with motor winding factories, battery assembly plants, and carbon fiber fabrication workshops, all within a few hours' drive of their headquarters. Furthermore, and this is crucial, these Chinese firms aren't starting from zero. Companies that build heavy-duty drones for firefighting, agricultural spraying, cargo transport, and industrial inspection have already solved many of the core engineering challenges that a personal VTOL aircraft requires. Flight stabilization software? They've been refining it for years. Energy management systems? Standard practice. Powertrain optimization for heavy payloads? That's literally their day job. For these companies, transitioning from a 200-kilogram cargo drone to a Jetson One-style personal aircraft was not a massive technological leap. It was an incremental step. And then there's the regulatory environment. The Civil Aviation Administration of China, the CAAC, has worked closely with drone and eVTOL manufacturers to create clear pathways to certification. China's framework for ultralight aircraft has been established under Chapter O of CCAR 91, which mirrors the FAA's Part 103 in many ways. An aircraft under 116 kilograms can operate recreationally without airworthiness certification or a pilot's license. So let's put all of this together. You have a product, the Jetson ONE, that is selling like absolute hotcakes at a price that keeps climbing. You have an entire industrial ecosystem in China with direct access to every component needed to build that product. You have engineering teams with years of relevant experience, and you have a regulatory framework that makes it legal to fly. The only question was never if Chinese competitors would emerge. The question was how fast. The answer, very fast. Before we dive into the Chinese competitors, I want to be fair to Jetson, because what they achieved is genuinely remarkable, and it would be dishonest to reduce it to just a scaled-up drone. The Jetson ONE you see flying today is the product of years of iterative engineering, multiple prototypes, countless test flights, failures, crashes, redesigns, and breakthroughs that happened behind closed doors, long before the viral video made the world take notice. Their final design, the specific arm geometry, the coaxial rotor configuration, the roll cage structure, the center of gravity positioning, the control response tuning, all of that represents accumulated knowledge that cannot simply be reverse engineered by looking at photographs. Jetson also developed a dedicated flight simulator for pilot training, a detail that speaks volumes about their focus on safety and usability. They're not just selling a product, they're building an ecosystem, training, support, community, and continuous software updates. No other company, Chinese or otherwise, has Jetson's holistic understanding of this specific design. They lived with it. They evolved it. They understand its quirks, its limits, and its potential in ways that a copycat never will. That matters. It matters a lot. And as we look at the competition, keep that context in mind. Now, Tyson, let's meet the challengers. Through extensive research, including scouring Chinese social media platforms, tech demonstration videos, manufacturer websites, and international trade shows, we've identified at least 4 Chinese manufacturers producing personal VTOL aircraft with designs strikingly similar to the Jetson ONE. There is visual evidence of at least 1 or 2 additional manufacturers beyond these 4, but information is extremely limited. Many of these companies have minimal English language web presence, and the language barrier makes detailed research challenging. Much of what we know has been extracted from TikTok videos, Douyin clips, short tech demos, and scattered spec sheets. Let's break them down one by one. The first and most prominent challenger is the S0, or S0, built by Shenzhen Yingwu Intelligent Technology Company, commonly known as eVTOL. Among all the Chinese Jetson clones, the S0 appears to be the most developed, the most tested, and the most market-ready. It was reportedly developed in collaboration with Shenzhen University, which lends it a degree of academic credibility that the other competitors lack. Visually, the S0 is unmistakably inspired by the Jetson ONE. The same open aluminum roll cage cockpit, the same four-arm configuration with coaxial rotors, the same general proportions and layout. If you put a Jetson ONE and an S0 side by side, you'd have trouble telling them apart from a distance. But there are differences. The S0 uses larger propellers, over 1 meter in diameter compared to the Jetson ONE's roughly 0.9 meter blades. These larger propellers generate more thrust at lower RPMs, which theoretically translates to slightly longer flight times. eVTOL claims approximately 25 minutes of flight time compared to the Jetson ONE's 20 minutes. The S0 also features an interactive display screen, something the Jetson ONE doesn't currently offer in its minimalist cockpit design. This screen reportedly shows real-time flight data, battery status, GPS information, and potentially navigation assistance. Here's where it gets really interesting. eVTOL has announced a price for the S0 of just $59,000. Let me say that again. $59,000. And that is less than half the Jetson ONE's upcoming price of $140,000. And this isn't just a paper announcement. Videos circulating online suggest that at least one unit has already been delivered, reportedly to a customer in the Middle East. Now, is the S0 as refined as the Jetson ONE? Almost certainly not. Jetson's years of iterative development, their proprietary control software, their safety testing protocols, and their pilot training ecosystem represent value that doesn't show up on a spec sheet. But at 59,000 versus 140,000, that price gap is enormous. And for many potential buyers, especially in markets where price sensitivity is high, that gap will be decisive. The second competitor comes from a company called Global UAV, a Chinese drone manufacturer that has been building heavy-lift commercial drones for years. Global UAV's entry into the personal VTOL market follows the same playbook: an open-frame cockpit, coaxial rotors on four arms, an aluminum structure designed for a single occupant. The visual similarity to the Jetson ONE is undeniable. What Global UAV brings to the table is their existing experience in heavy payload drone operations. Building drones that can carry 50, 100, even 200 kilograms of cargo means they've already solved critical engineering challenges around motor reliability, battery management under heavy load, and structural integrity during sustained flight. Transitioning that expertise to carry a human instead of a cargo container is, from a pure engineering perspective, a lateral move rather than a vertical one. Details on Global UAV's personal VTOL specifications are scarce. The company appears to require prospective buyers to provide personal details before disclosing pricing, a common practice among Chinese B2B manufacturers, but one that creates opacity for outside researchers and consumers. What we can say is that industry observers believe Global UAV's pricing could potentially undercut even eVTOL's $59,000 price point. If true, that would put a personal flying machine in the same price bracket as a mid-range SUV. The third challenger is Skytech UAV with their aircraft called the eVTOL, a name that isn't exactly subtle about their ambitions. Like Global UAV, Skytech comes from the commercial drone industry and has adapted their expertise for the personal VTOL market. The eVTOL follows the now familiar formula: open cockpit, four-arm coaxial rotor configuration, single-seat aluminum frame. Skytech, like Global UAV, keeps its pricing information behind a contact form, requiring potential buyers to reach out directly before any numbers are shared. This lack of transparency makes direct price comparisons difficult, but the assumption within the industry is that Skytech is targeting a price point competitive with or below eVTOL's S0. The eVTOL has appeared in various demonstration videos showing basic flight capabilities: takeoff, hover, translation, soar and landing. However, the depth of testing, the safety protocols, and the software maturity remain unclear from publicly available information. Beyond these three, there is visual evidence, scattered across Chinese social media, of at least one additional manufacturer producing a Jetson ONE-style personal VTOL aircraft. Brief clips showing similar-looking aircraft in flight have surfaced, but without identifiable branding, company names, or specification data. This is the Wild West of personal aviation, and it's happening largely below the radar of Western media. So how do these aircraft actually compare? Let's break it down across the key dimensions that matter. Starting with design and build quality, the Jetson ONE's aluminum roll cage cockpit is the result of iterative refinement. Every tube angle, every joint, every structural element has been tested through multiple design generations. The Chinese competitors have largely replicated the external appearance, but whether they've matched the structural integrity and crash protection of the original is an open question. Without independent testing data, we simply don't know. Propulsion. This is where the Chinese aircraft actually show a potential advantage. By using larger propellers, over 1 meter versus the Jetson ONE's roughly 90 centimeters, the Chinese designs generate more lift per revolution, which reduces power consumption and extends flight time. 25 minutes versus 20 minutes may not sound dramatic, but in an aircraft where every additional minute of flight time represents meaningful engineering progress, it's noteworthy. However, the Jetson ONE's more compact propeller size gives it a smaller overall footprint, better agility, and quicker response to control inputs. It's a classic trade-off: efficiency and endurance versus maneuverability and compactness. Jetson chose compactness. The Chinese competitors chose endurance, flight software, and control systems. This is where Jetson holds its strongest advantage, and it's an advantage that's nearly impossible to see from the outside. The Jetson ONE's flight control software has been developed and tuned over years of real-world testing. The specific gains, the PID tuning parameters, the fail-safe protocols, the sensor fusion algorithms, all of that represents accumulated intellectual property that cannot be copied by photographing the airframe. Jetson has also developed a dedicated flight simulator for pilot training, which signals a level of commitment to safety and user experience that goes well beyond just building hardware. The Chinese competitors are likely running flight control software adapted from their commercial drone platforms. This software is capable and proven in drone applications, but controlling an aircraft with a human on board introduces entirely different safety requirements, response expectations, and failure mode considerations. Whether the Chinese software has been adequately adapted for manned flight is, at this point, unclear. Safety. This is perhaps the most important dimension, and it's where the picture gets concerning. Jetson's own demonstration videos rarely show flights more than a few meters above the ground. This is almost certainly a deliberate safety choice. At low altitude, even a complete power failure results in a relatively short fall. Painful perhaps, but survivable. The Chinese competitors, by contrast, frequently appear in videos flying at significantly higher altitudes. While this makes for more dramatic footage, it also raises serious questions about safety protocols. What happens if a motor fails at 50 meters? What fail-safe systems are in place? Is there a ballistic parachute? What are the redundancy mechanisms? These are questions that don't have clear public answers for most of the Chinese aircraft. And in a field where a single catastrophic failure can kill the pilot, unanswered safety questions are not just concerning, they're potentially deadly. And now we arrive at the number everyone's been waiting for. The price comparison. The Jetson ONE, the original, the pioneer, the aircraft that started it all, is currently priced at approximately $128,000, with an announced increase to $140,000 coming soon. The eVTOL S0, the most developed Chinese competitor, has been announced at $59,000. Let that sink in. The gap between the Jetson ONE and its closest Chinese rival is approximately $81,000. That's not a small difference. That's the price of a luxury car sitting between the two options. For that $81,000, what do you get with the Jetson? You get years of proven design evolution. You get refined and extensively tested flight control software. Once you get a dedicated training simulator, you get a company with a track record of customer deliveries and ongoing support. You get the confidence of buying from the brand that invented this category. With the S0, you get a significantly lower entry price, potentially longer flight time, and an interactive display screen. But you also get uncertainty. Uncertainty about long-term reliability, software maturity, safety testing depth, and after-sales support. Is the Jetson ONE worth more than twice the price of its Chinese rival? That depends entirely on what you value. If you value proven safety, brand trust, and engineering heritage, yes, absolutely. If you're in a market where price is the primary driver and you're willing to accept higher uncertainty, the Chinese options become extremely tempting. And this is the exact same dynamic that played out in smartphones, in electric vehicles, in consumer drones, and in virtually every technology category where Chinese manufacturers have entered. Premium Western brands compete on quality, trust, and ecosystem. Chinese challengers compete on price and rapid iteration. History suggests that both can coexist for a while. But history also suggests that the gap narrows over time. And if the Chinese competitors invest in safety testing, quality control, and customer support, that $81,000 gap could become very difficult for Jetson to justify. Here's the bigger picture, and this is what makes this story genuinely important beyond just comparing two aircraft. The emergence of Chinese competitors doesn't diminish what Jetson has achieved. If anything, it validates it. When an entire industry springs up to copy your product, that's the ultimate confirmation that you built something the world wants. But competition is competition, and the personal VTOL market is about to enter its most critical phase. Over the next few years, we'll see prices drop, technology improve, regulations evolve, and public awareness grow. The company, or companies, that navigate this phase successfully will define personal aviation for a generation. Jetson's path forward likely involves continuing to refine their product, expanding production capacity to bring costs down through scale, and doubling down on their safety record and brand trust. They need to make the case that the Jetson ONE isn't just a flying machine, it's a complete ecosystem of training, support, and community that justifies its premium price. The Chinese competitors' path forward involves proving that their lower prices don't come at the cost of safety. They need independent testing, they need transparent safety data, they need demonstrated reliability over hundreds or thousands of flight hours. Price will get customers in the door, safety will keep them alive. And for you, the viewer, the potential buyer, the person who's ever looked up at the sky and wished you could just go, this competition is the best thing that could possibly happen. Because competition drives innovation. Competition drives prices down. Competition accelerates the timeline from cool tech demo to normal part of everyday life. The day when a personal VTOL aircraft costs as much as a family car and is as safe as driving one, that day is coming. And this rivalry between Jetson and its Chinese challengers is helping to bring it closer. So here's the question I want to leave you with, and I genuinely want to hear your answer in the comments. What is the right price for a personal flying machine? Is Jetson's $140,000 fair for the quality, safety, and heritage you're getting? Would you trust a $59,000 Chinese alternative with your life? Or is there a number somewhere in between that feels right? Drop your thoughts below. I read every single comment, and this is a conversation worth having. You can find a full detailed specification comparison of all the aircraft mentioned in this video on our website. The link is in the description. If this video opened your eyes to something you didn't know existed, do me a favor. Hit that like button. Subscribe if you haven't already. And share this video with someone who's ever dreamed of flying. It helps the channel more than you know. Until the next one, keep looking up.